of that. So really, you're breaking. We only have like 6 options. It's going to be either like 1, 2, 3, 6, or negative 1, 2, 3, or 6, isn't it? There's not that many options actually when you realise it has to be a factor of that number there. So what does this give us an answer of, by the way? Does anyone put that into their calculators?
It's 0.
It's 0, is it?
Yeah.
Okay, so if that's 0, what that means is that the purpose of doing that is that means therefore x plus 2 is a factor of p of x. So that's how we now know what one of the factors are.
Or is it 2 or negative 2?
It's plus 2, so it's always the opposite.
What's the other answer?
Well, there's 2 other answers, isn't there? So we know it's going to break up into 3 factors. So what do you think we might be able to do if we know that x plus 2 is a factor?
So we can add that as one.
That's going to, how do you think we're going to find out what the rest of it is though?
No, but like what in that equal sign?
Yeah, hand in.
Above, go up.
Yep.
Up. Down.
So that's just I've written down. We know that's a positive. So we know because all the full terms are. We didn't really bother working that because we know they're all going to be full positive terms. That's not going to be 0, is it? We're just looking for one that's actually going to give us an answer of 0. That one's not. That one is 0. So that one we know is a factor. Yes, Alan?
How did you get x plus 2 as a factor?
Because when you sub in minus 2, right, it's always the opposite sign that gives you the factor.
Oh, okay, yes.
So that's if that was a 2, the factor would be minus 2, and vice versa as well. So what should happen now? The purpose of this now is if we now take this and divide it by that, if this is a factor, what should the remainder give us? If we did this divided by that, knowing this is a factor, what will the remainder be at the end? Yep, 0, won't it? And the bit we have left will be the bit that's left after, like the quotient will be what it actually equals when you divide them.
So it's time to figure out qx if you haven't done it.
So what we can do now is we can say, okay, if we do x plus 2 divided by this, so if we have plus 11x plus 6, so if we do this division here, this will tell us what's left after we've done the division, and it'll tell us and we can actually break it down to the 3 different factors. So what's x? Let's go through this process again. We've done this yesterday. What's the process here? So we've got x cubed divided by x gives us x squared. So that's division, multiply. So now we go x squared times x cubed, x squared times 2x. 2x squared, and then you take it away. 0, 6x squared, take 2x squared is?
4x squared.
4x squared. We bring down the next term. And now we just keep repeating, don't we?
Yeah.
So now we just go 4x squared divided by x is what? 4x squared divided by x? 4x. Then we multiply. So 4x times x, 4x squared, 4x times 2, 8x, and we subtract 0, so we always want that leading part to be 0, plus 3x, then we drag down the last one, then we just repeat again, don't we? So what's...
Why is it plus 3x?
Because 8 so 11 take 8 is 3. So 4x...
Plus 1 though.
Yep, that's it, but remember we always subtract that there.
Could you not just say then that x plus 2 could divide into 3x plus 4? So 3x plus 6?
It divides into this part here.
So could you not say what we've got left over would go straight into what we're dividing by?
Yeah, and I'll show. Yeah, that's what we're talking about in a second. So let's finish this off. So we go 3x divided by x is just 3, isn't it?
Wait, what are the these things below the division?
What things below the division? These things.
Yeah.
That's remember the bit where we multiply, so we know what we're going to subtract. This is the same process we did yesterday. We'll go.
Meg wasn't here yesterday.
Okay. Well. So if we have now we multiply, you go 3x times, so 3 times x is 3x, 3 times 2 is 6, and then we subtract, and because it's a factor, there's no remainder, is there? Can we see that? So there's no remainder, so this here, so what that's telling us now is that if we, this here, so this expression can be written now, we break it down to 2 factors, x plus 2, and then 2x plus 4x plus 3, haven't we? X plus 2, and then x squared plus 4x plus 3. So if we multiply this out, so remember this is the reverse of division.
Would we do another term which would be x plus 3, x plus 2, x
Good.
plus 1?
Yeah, good. So we could further factorise that, couldn't we, as well? Now, but what I want us to realise that this is the important thing, is that this here, so this expression here, if we multiply this out, did the reverse of dividing, it would give us this, wouldn't it?
Yeah.
So what we've actually done is we've factorised it. And then, as Caleb pointed out, this can be factorised based on on that method we learned in term 1. It can become equal to x plus 2, that's one of the factors.
X plus
And then it becomes x, so two numbers multiply to this and add to this. So it's x plus 3 and x plus 1. So that's that factorising thing we did in term 1.
What's that question?
So what we've done now is this now is fully factorised. So this is what we call fully. So the purpose of this was to fully factorise it, and this is now fully.